everyone, welcome back to this video tutorial. We can discuss about the interrupt action relating to 8086 processor. So first we can consider about what is an interrupt and what are its requirement. Okay, so the microprocessors allow normal program execution to be interrupted in order to carry out a specific task. Okay, sometimes the microprocessor want to interrupt the currently executing program in order to execute certain other important task. Okay, the process of interrupting the normal program execution to carry out a specific task or work is referred to as an interrupt. So this is the definition of an interrupt, the process of interrupting the normal program execution in order to carry out a specific task. The process is actually known as an interrupt. Okay, the processor can be interrupted in following two ways. What are they? First is the way of hardware interrupting and second is the software interrupting. Okay, hardware interrupt or external interrupt means the interrupt generated by external peripheral devices. Okay, like keyboard interrupt or interrupt signal generated by some other input, output or peripheral devices. Okay, so externally or internally we can generate the interrupt. Okay, so next is about the software interrupt, the internal signal generated by a special instruction in the program. That means while executing certain special instruction like INT instruction present in our program, it will automatically generate certain instruction based on the type of that INT instruction. Okay, we have already discussed about this INT instruction in our previous video and the video relating to the instruction set, right? So while executing certain INT instruction which is present in our program, it will generate certain interrupt based on the type of that interrupt. So this is an example of software interrupt. One more case in relating to the software interrupt, that is while executing certain certain instructions, like in case of looping and or it may generate certain exception in our program. Okay, such exceptional cases or condition may generate software or internal interrupt. Some best examples are like division by zero interrupt. In some cases in our program, as an exception, it automatically divides certain number by 0. This is a case of exception and such exception will generate certain interrupt automatically. And sometimes we are going to store a large number of values which may exceed the type of the storage space or which may exceed the allotted memory space. Such cases it generate the overflow. So such overflow is also automatically generate certain overflow interrupt. As a result, certain warning messages or error messages may arise onto the output screen. Okay, so these are some basic type, or generally we can classify that interrupt as hardware interrupt and software interrupt, or internal interrupt, hardware interrupt means external interrupt or software interrupt means internal interrupt. Okay, so next is about an overview of the interrupt action. Okay, what are the steps? Basically, what are the steps involved in an interrupt action? When a microprocessor receives an interrupt signal and if it is ready to accept the request, then stop executing current normal program and save the status information. The status information like the values of various registers like instruction pointer register, code segment register and flag register onto the stack top. Okay, so first the processor receiving an interrupt signal, and if the processor is ready to accept the signal, whenever the processor become ready to accept, this is relating to the priority of the received interrupt signal. If the received interrupt signal having higher priority than the currently executing program, then it automatically stop the current program execution or interrupt the current program execution and store the status information onto the stack top. Then processor execute as subroutine or procedure. Then processor become ready to execute as subroutine or procedure in order to perform, in order to support the interrupt request. Okay, so the subroutine or procedure that is executed, that is going to execute as a response to the accepted interrupt request is known as the interrupt service routine, right? So what is an interrupt service routine? The procedure or the subroutine body that is going to execute as a result of accepted interrupt request. The such subroutine or procedure is known as the interrupt service routine, subroutine or routine. Okay, ISR. At the end of interrupt service routine, the stored status of registers like content of IP register, CS register, and the flag content we have already stored onto the stack top. Then only the processor is going for the execution of interrupt service routine. So after completing the interrupt service routine execution, we need to pop back all these register content one after another, like IP, CS and flag register content one after another back to the respective register. Then processor resume the normal program execution from the point where it was interrupted. Okay, so this is an overview of the interrupt action, right? So we need to consider some more. That is, whenever number of devices interrupt a CPU at a time and if the processor is able to handle them properly. If more number of devices interrupt a CPU at the same time and if the processor is able to handle them properly, it is called multiple interrupt processing capability of our processor. Okay, so in A0, A6 there are two interrupt pin like NMI and INTR. So this is the pin diagram of A0, A6 processor. Here we have two special pin, that is NMI and INTR, 17th and 18th pin. Okay, NMI is a non-maskable interrupt input pin, which means that any interrupt request at NMI input cannot be masked or disabled by any means. What's the meaning? So whenever an interrupt request arises through the 17th pin, processor need to stop whatever program the processor is currently dealing with. The processor want to stop the execution of that particular program and must accept the request through this 17th pin. Okay, because this indicates the interrupt request arising through the 17th pin must be accepted as soon as when the request arises through this pin. Okay, so whenever a request arises through the 17th pin, processor stop the current program execution after completing the currently executing single instruction. Right, after completing the currently executing single instruction, it stop the program execution and go for dealing the interrupt service routine relating to the request arise through the 17th pin, because the interrupt request arise through the 17th pin indicate a non-maskable interrupt request. Okay, so whenever a interrupt request arise through this 18th pin, the pin is actually an interrupt request. So whenever a request arises through this 18th pin, the processor want to check the status of interrupt flag. Okay, the processor want to check the status of interrupt flag. If the current value of interrupt flag equal to 1, then only processor want to accept the request to this INTR pin. Right, so whenever this processor receives an interrupt request through this 18th pin, suddenly the processor want to check the status of interrupt flag. If it is equal to 0, then processor simply neglect that request and continue its current execution. And whenever the processor receives an interrupt request through this 18th pin, Then processors check the current status of interrupt flag value. If it is equal to 1, then processor stop the current program execution after completing the current single instruction execution, then go for executing the interrupt service routine relating to the request arise through this 18th pin. Okay, from this it is clear that 17th pin indicate non-maskable interrupt and 18th pin, this is a maskable interrupt, and whenever an interrupt request arises through this 18th pin and its priority relating to the value of or status of our interrupt flag. Okay, if the value of that interrupt flag equal to 0, the processor can simply neglect the request. If the value of the interrupt flag equal to 1, then processor need to consider this request and we need to, or the processor need to execute the interrupt service routine relating to the type of the request arise to this 18th pin. Okay, so this is a case of maskable interrupt and this is non-maskable interrupt. So these two are also type of interrupt, maskable and non-maskable interrupt. We have other classification for interrupt like internal or external interrupt. Okay. So INTR is of 256 types. So we can consider different interrupt and totally the interrupt are divided into different type and totally we have 256 different types of interrupt. And these 256 types of interrupts are numbered from 0 to 255. So total 256 different types of interrupts are available in 8086 including both INTR and NMI interrupt and they are numbered from 0 to 255. If more than one type of INTR interrupt occur at the same time, then an external chip called a programmable interrupt controller is required to handle them. This is a situation if more than one type of interrupt occurs at the same time. That means the 18th pin is receiving more than one interrupt at the same time, then an external unit, that an external interrupt controller unit is required for deciding which instruction going to handled by the processor first. Okay, so here we need an external unit, that is the interrupt controller unit, in order to handle multiple interrupt requests. Okay, so all these are about some basic steps including interrupt action. In next video we can discuss about the interrupt cycle and their activities included in interrupt action of 8086 in detail. Okay, thank you.